Good morning, students. We are moving to another topic per se today, and the fourth topic is called the what? Elementary structure of an atom. And under this topic, I would like you to prepare your mind. It's something that you are aware with, but you have been doing it in chemistry. But after this, we're going to talk about some simple formula with a simple solution. But you can write first. Elementary structure of an atom. An atom is made up of a positively charged nucleus orbited by a negatively charged electrons. The nucleus of an atom consists of neutrons and protons, which are also called nucleons. Full stop. The diagram below shows a simple helium atom with the nucleus containing 2 protons and 2 electrons. Let me show you the diagram. Look at this diagram. I'm still coming back to that. When you have something like this, then you have what we call neutron. That is, we have nucleus. And inside the nucleus, you have, because we are talking about the helium, as you can see that when you're talking about the helium has 2 protons and 2 neutrons. So definitely, let's assume we have 2 neutron, then 2 of proton. You can see that. Now, what they are saying in essence is this: there's something is moving around this. That is what we call our electron. But let me blow your mind. In the last class, we have been talking about the atomic model. We tried to explain J.J. Thomson model. We explained Rutherford model, and we equally explain Bohr's model. As you can see, is step by step. J.J. model was able to discover that the atom has a positively charged sphere body, and embedded in it we have what we call electron. This man finds it so difficult to explain the arrangement of this positive charge and the what? And the electron. Before the Rutherford came on board, and Rutherford, through his experiment that we call metaphor experiment, that is the passage of an alpha particle to move or to eat a metaphor, now discover that at the center of an atom there is an heavy mass. That is why when the alpha particle is moving, alpha particle finds it so difficult to pass through it. I get me. It has to rebound it back. That is what makes this man to discover this thing that we call nucleus. We call it nucleus. But this man also appreciates the electrons. This man is talking about, J.J. Thomson was talking about, that is embedded within the positive charge sphere. But this man discovered that this object was moving around this nucleus. Now, when Bohr's model, that is, Bohr came on board, this man was able to tell us the arrangements of this. I get that. So it's the one that let us know that this electron was moving in an orbit around the nucleus. But now this is what the structure, the structure of a modern day atoms is now talking about. They are making us to realize that this nucleus, what do you call the name of the Rutherford discovered another thing here that we call the nucleus. I get that. The J.J. Thomson discovered the positively charged inside the atom. That is, the whole atom is positively charged. But Rutherford now discovered that positively charged is within the center of the atom. But thereafter, the Rutherford discovered that inside this nucleus, the Rutherford discovered, I get it now, that we have another particle inside that. And that particle is what he called neutrons. And he told us that neutron had the same amount of mass with the proton. That means inside the nucleus now, we have what we call the protons and the neutron. But the proton is positively charged as discovered by J.J. Thomson. I get it now. But the neutron has no charge, but it has the same mass as the proton. But electron moving around them is negatively charged. That is why they are now electrically balanced. That is why this object can move, the electron can move around it. Hope you understand what we're talking. But let's move on. Let's move on. You can put down the diagram. Now, the atomic nucleus of an element X is denoted by this. It's denoted by this. X of A and Z. That is the atomic nucleus of an element, where X is the element, A is the mass number, Z is the atomic number. Should I come again? You have X is the element, A is the mass number, and Z is the atomic number. But that mass number, this mass number that it is what we call the what? The mass number. Hydrogen is also known as nucleo. It's also known as nucleo number. Do you get that? So let's move on. Let's now give the meaning of this mass number and what? An atomic number. Paragraph. Mass number. Mass number is the number of protons. Mass number is the number of protons and what? And neutron in the nucleus of an element. Mass number is the number of protons and neutrons in the nucleus of an element. Full stop. It is also called nucleo number. You can see it is also called nucleo number. That is another name for what? For mass number is what we call nucleo number, which simply means that the total sum of the protons, so total sum of the protons and what? And neutron. And neutrons in the nucleus of an element. That is, this is what they are saying. That is inside this. Inside the nucleus, inside this nucleus, we have two things: the protons and the what? And the neutrons. And this proton and the neutrons is what made up the what? The nucleus, which we also call nucleo number. So let's move on. Let's go to this Z. That's Z. That's what we call it. Or let me, before we go to that side, let's quickly show this mathematically. When you are talking about the atomic number, you can write. The mass number is mathematically given by this. That is, you can have mass number. You can have mass number to be equal to what? To the number of protons. Numbers of protons plus number of neutrons plus number of neutrons. So you can have it as what we call the what? Mass number. That is A. Number of protons, that is capital letter B, P rather, plus number of neutrons, that is capital letter N. So this is what you need to recall at any point in time. That is A equal to P plus N. So let's move on. Paragraph. Atomic number. Atomic number. That is our Z. This is what we call atomic number. atomic number. We call this atomic number. Atomic number. Now you can write atomic number is the number of protons in the nucleus of an element. So is the number of protons in the nucleus of an element. Full stop. Mathematically given by. Now look up. We are talking about the atomic number as the number of protons in the nucleus of an element. That means if I want to imply, I can have atomic number. I can have atomic number to be equal to the number of protons. To be equal to the numbers of protons in the nucleus of an element. So take note of that. That means from here, atomic number is A, which is also equal to number of protons equal to what? P. That is what we call atomic number. Okay, atomic number should be Z. Sorry for that. Atomic number should be Z, which is now equal to P. So let's move on. But take note of this. The relationship between mass and atomic number is given by. I want to talk about the relationship between atomic number. Okay, let me put this point here. Relationship between the atomic number and what? And the mass number. Normally, if I imply that what? A atomic number equal to what? The number of proton plus the number of neutron in the nucleus of element. But you know that the atomic number is the same thing as the number of proton. Do you get that? Atomic number is number of proton equal to the number of proton, and the atomic number is denoted by Z. So at the end of the day, I can have mass number should now be equal to atomic number plus the neutron. Do you get that now? So that will be the relationship between the two. So let's move on. Now put this down. Note the particles, that is the particles inside the nucleus. The particles inside the nucleus are called nucleus. Nucleus. Where is it? Nucleus. Can you see that? That is this particle inside the nucleus, which are what? Which are the protons and the neutrons are referred to as nuclei. Take note of that. Now let's quickly move on to isotopes before we really use this isotope. Can you see this before I rub it up? Isotopes. Okay, maybe I will still come back to this diagram, but let me rub up this side. Isotopes. I want to talk about isotopes. Isotope, I believe in chemistry you have been talking about that as a topic. Isotopes. Isotopes. If I may ask anybody to give me the meaning of isotopes, I believe you can talk about that. I think you are right. Isotope is the number. You can write isotope. Isotope is an atom. Let me put that way. Isotope is an atom of the same element. Isotope is an atom of the same element which have the same atomic number but different mass number. Can you get it? That is, isotope is an atom of the same element which has the same atomic number but different mass number. Full stop. Let's move on. They have similar chemical particles. No, they have similar chemical properties because they have the same number of electrons, because they have the same number of electrons around the nucleus. If I should ask you to give me an example of isotope, you know, chlorine is a typical example of isotope. So you can write example, chlorine. That would be chlorine 3517. That means chlorine 35. Chlorine 35, 17. Our chlorine 37, 17, 37, 17. Now, from the meaning of an isotope, let's move on from the meaning of an isotope. What do we, this 35 in this case is what? Is what? This 35 in this case, what will you call that? From what we just, okay, I brought it up from what we just explained, we call that A to be equal to what? Mass number. Why we call the 17 in this case, which is Z, we call it what? Atomic number. Atomic number. So, talking about the meaning of isotopes now, they are telling you that the isotopes are atoms of the same what? Of the same atomic number. You can see 17, of the same atomic number, but different mass number. That is what they are saying. Do you understand that? And they are telling you that you know that when you are talking about the what? The mass number is the number of protons. Is the number of protons and neutrons in the nucleus of an element. While your what? The atomic number is just the number of protons in the nucleus of an element. That is what isotope is talking about. So you know that we have chlorine 35, 17 and chlorine 37, 17 as a typical example of isotopes. But let's see this question. Let's go to calculation under this. You can put it down. Calculation. Number 1. What is the nuclear number of helium? What is the nuclear number of helium with 2 protons and 2 neutrons? They said they are asking for what is the nuclear number of helium with 2 protons and 2 neutrons. 2 protons and 2 neutrons. So let's see that. Now, but before I go to that question, let me go back to this. When we're talking about the mass number, we talk about the mass. Those are the things we need. Mass number, which is what we denote it with what? A. We said, okay, let's say mass number. Mass number, that is A, which is also equal to the number of protons plus neutrons in the nucleus of an element. That is, at the end of the day, I can have A to be equal to P plus N. Can you still remember this? Now, again, let me now go back to atomic number. Atomic number, which is Z. If I imply atomic number should also be equal to the number, atomic number, which is what? Which is Z. Which is Z is equal to the what? Is equal to the number of protons in the nucleus of an element. So at the end of the day, I know that Z equal to P. So this equation here will now become A equal to what? Z plus N. Now, let's go back to that question. They said, what is the nuclear number of helium with 2 protons and 2 neutrons? That means from that given question, I can have the proton is given, the proton, 2 protons. The number of protons is 2. Then the number of neutron is also 2. And they were asking us to find the nuclear number. But if we are talking about the nuclear number is still the same thing as the what? At the mass number. That is, if I imply that nuclear number should now be equal to what? Equal to mass number. So at the end of the day, I can have nucleus, which is A, should now be equal to P plus what? Plus neutron. So and the proton in this case should now be equal to 2 plus 2. That means the nuclear number will now be 4. Can you see that now? The nuclear number will now be 4. So take note of that. Now let's see another question, number 2. What is the proton number of oxygen with 8 electrons and 8 neutrons, and hence its nuclear number? You know, they are asking for 2 things, but let's bring out the parameters first. Let's bring out the canaries of this. Then we bring out the parameter. From that question, what is the proton number of oxygen? We are looking for the proton number of oxygen. No, what is the proton number of oxygen with 8? Yes, they are asking what is the proton number of oxygen with 8 protons. From here, we have proton to be what? To be 8 from the parameter. No, they are asking for it. Proton is that with 8 proton and 8 electron and 8 neutron. Number of neutron is also equal to what? Equal to 8. Now, but now they are asking for the proton. They want to find the number of proton. So if I'm talking about the number of proton, should now be equal to the what? Number of proton is same thing as proton number, which is P. So at the end of the day, this is now equal to 8. Number of proton is still the same thing as what? Proton in that nucleus of that, or in that nucleus of oxygen. But now the second one I said, and hence the nuclear number. And you know that the nuclear number is same thing as mass number. Do you remember that? That is still here. Nuclear will imply that nuclear number also equal to what? Mass number. So which is still the same thing as A equal to what? P plus N. So at the end of the day, you have A. We are looking for that, and then the P, number of proton, that should still be what? 8. Then the number of neutron, that should still be 8. That should now be what? 16. That is why you have the mass number of oxygen to be 16. Do you understand that now? And the number of proton is also 8, which is still the same thing as the word atomic number. Do you get that now? So that is what they are saying. But I would like you to do this on your own. Take this question, take it as the class work. We have number 1. In what ways are the isotopes of a given element? In what ways are the isotopes of a given element? Room have got 1, different from each other. Room have got 2, similar to each other. Take that question and do it. Then during the class discussion hour, then I will ask question. I will ask you about that. But the second one here, let me give you this table. I have one table here. The second one. The second question I will give you number 2. Number 2, we have atom. It's a table. We have atoms. Then here we have number of atoms. We have number of atoms. Then the number of protons. Sorry, we have number of protons. Number of protons. Then we have number of neutrons. We have number of neutrons. We have number of neutrons. Under this we have X element. Then under X element, for number of protons we have 4. For number of neutrons we have 3. Then we have element, atom of Y, that is element Y. Then under the number of protons there we have 3. And under the number of neutrons we have 4. Then the last one there we have Z, atom Z. Then under the number of protons we have 4. And under the number of neutrons we have 4. So this table is what I want to give you at the second question. But under this Roman figure 1 there, you can take this Roman figure 1. Which of the atoms in the table above are isotopes? They're asking you which of the atoms here. I get to know which of the atoms in the table above are isotopes. Then, comma, full stop. Give reason. Why are they isotope? I think the other time I used chlorine 35 with atomic number, mass number this, and this chlorine 37 from 17. From this you can get the meaning of what? Of isotope. And that is what they are trying to ask you there. What makes them to be an isotope? If it is X and Y, what makes them to be an isotope? That is what they are asking for by give reason. Then number 2, you might go to there. How are protons, comma, neutrons and electrons distributed in the atom of an element with atomic number 3 and mass number 7? Do you understand the question? How are protons, neutrons and electrons distributed in the atom of an element with atomic number 3 and mass number 7? What they are asking you to do is to give the number of protons you have, the number of neutrons you have, and the numbers of electrons you have under this question, in which the atomic number is given and the mass number is given. I hope you enjoyed this class. Before our next class, just take care of yourself. Thank you.